name is my name is Alfred Raymond, as has introduced me, and today we're gonna have a class. Can I say a class? Because I assume you are my students right now. So, all right. So I'm going to share my screen so that we can start this. Okay. Host, can you enable screen sharing, please? Hello?
Hello, I can hear you.
Yes, I'm asking if you can enable screen sharing. It has been disabled.
Okay, let me disable.
Okay. Hello. I think I still cannot share, but okay. While at it, I can just start. Like today, we'll be talking about the basics of Git and GitHub, and as the topic suggests, we'll be talking about two different things. Like there is Git, and also there is GitHub. So first, uh, we have to understand what is Git. Okay. Host, please, can you enable the screen sharing? Okay. So Git is a free and open source distributed version control systems that is designed to handle everything from small to very large projects with speed and efficiency. You can find like the history and everything about Git through git csm.com, but I'll just go directly to tell maybe what is a version control system. It would be great if we can all see this presentation here, but
Can you check now?
all right, thank you. I'm supposed to share my screen. Oh, I think like I have a problem. So sharing my screen. Okay. Portion of the screen. Yes. Which portion? One. Ah. Oh. Like, can everyone see my screen right now? I don't know.
Still loading.
Well, you are sharing, but it's blank.
Okay. Let me try again. What about right now? Not yet.
Still loading.
It is loading. Okay, let me do this. Okay.
Okay, is it what kind of presentation is it? Is it slides or?
Yes, it is a Google slide. It's a Google Doc.
Okay, can you send me it so that I can share
Yeah, sure.
on? Yeah.
Yeah, that would be very helpful. Yeah, let me send it. Let me send you the link. Okay. Can you write your? Okay. Write me your email if possible. Just write me on the chat here so that I can add you. Okay. Thank you. Yeah, I've sent you. Are you able to share? Yeah, that's better. Okay. Okay, so I'll start from what is Git, because as from our topic, the basics of Git and GitHub, first we have to understand what is Git. Git is a free and open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. And as we go with today's topics, we'll have a full understanding of what is Git and what is version control systems. And then we'll be able to discuss about what is GitHub and what can you do with it. So version control system is a system that records changes to a file or a set of files over time so that you can recall specific versions later. So here we say, like, for example, you can be a graphic or a web designer and you want to keep every version of an image or a web page that we have created. So normally when you want to change a document, you either have to create a copy of your content and then like create or rename that document and then change the file so that the changes cannot be overwritten. So that, let's say you can have two copies, like the first one is before editing and the second one is after editing. So version control systems allows you to revert selected files back to a previous state, revert the entire project back to a previous state, like compare changes over time, see who last modified something that might be causing a problem, like who introduced an issue and when, and more. And by using version control systems generally means that if you have messed up, let's say you have edited something very important and then you forgot what was the original content there before you edited it, you'll be able to go back and easily recover additionally anything that you have done. So you get all this for a little, with little efforts by using version control systems. So version control systems have various types. So we have local version control systems, we have centralized version control systems, and also we have distributed version control systems. Um, when I say local version control systems, I mean, it's kind of a copy or list of documents that are available in your computer. So like the local version control systems are like the folders in your computers. So many people version control system method of choice is to copy files into another directory. So let's say you want to modify, as I explained before, let's say you want to modify your Office document. So first you have to create a copy of that and then modify the new copy so that the original content of the previous copy does not be lost. We usually do this in, let's say, in Google Docs and everything. And this approach is very common because it's so simple, but also is also incredibly error prone. Let's say you can have multiple copies of a same document, and this can make your computer, let's say, uh, you can lose storage spaces because having redundancy of data and everything. So it is easy to forget which directory you are in and accidentally write the wrong file or copy of files you don't mean to. So this is local version control system, is like the file directory or file system of your computer. And then to deal with this issue, uh, programmers long time ago developed their local version control systems that had a simple database that kept all the changes for a file under revision control. So by saying that, I can try to explain for people who have came familiar with the word localhost or something, which like you can be able to store your files, record all the changes that have been done, and also be able to review, like see there's editing of last week and this week, but all of them are just stored on your computer. So when I talk about versions, I talk about revisions, I can refer this by uh, various distributions of the of certain files. For example, we have we see like we have Android versions, we have applications. Let's say we have Windows 7, Windows 8, Windows 10, and currently Windows 11. Those are kind of versions of the systems. And also you can have version of your documents, like the original file, and then you do some editing and then you save it as a different version, and then you add something different. That means you'll have to save it as a different version, and etc. So that's what I mean by a version. So like when you have version control system, this local version control system were designed, and it had a simple database that kept all these changes to a file under a revision control system. And then next we had centralized version control systems. Uh, this one, the major issue that people encountered is that they needed to collaborate. Let's say developers in the system, in the office, were working on projects. So that means if someone does a different changes, that means they have to share the files, like have them on floppy disk. I don't know, that it was, I can say, a long time ago. So like exchange them through flash drives or CD, and then another person has to copy it to their computer. So then they develop these centralized version control systems to deal with this problem. Like centralized version control system, it was developed to solve this issue of sharing files and also people to be able to collaborate to build things together within an office, or I can say within a network. So these systems have single server that contains all the versioned files and a number of clients that check out files from a central place. So like we can imagine like they had a server which stored all the files, and then people had access them remotely or through a network so that they can edit in there. Is how we do currently in our documents. Let's say I can send you a Google Doc link, and then we can participate in editing that together. And then this setup has offered many advantages, especially of a local version control system. For example, everyone knows to a certain degree that whatever everyone is in the project is doing. So they were able to share and also to see who is doing what where, and the administrator had a control of access, like who can do what, and it was easier to administer apart from the local version control systems. And then this setup had some serious problems. This like it had a single point of failure. So we can refer for those who have a knowledge of networking or something, like when you just have a single server, if it goes down, that means you can lose your whole history, you can lose everything, right? So from this problem, if the hard disk of the central database becomes corrupted, or the backup was not be kept, like the history will be lost, like everything, the entire history of the project. Expect whatever single snapshot people happen to have in their local machines can be lost. Like local version control systems suffered the same problem. Whatever you have the entire history of the project in a single place, you risk losing everything. Okay, so this is when after identifying different problems that arise from local version control systems and from these centralized version control systems, uh, distributed version control systems were developed. So this is where distributed version control systems step in, such as Git. There are various such as Git, Mercurial, Bazaar, or Darks. So clients don't just check out the latest snapshot of the file, like latest changes of the files. So what they do, they transfer them from their local machines, from their local servers to somewhere where it will be stored uh, permanently, or I can say safely. So if let's say the servers fail, they have a backup. Okay, so that's if any server dies and these systems are collaborating via that server, any of the client repository can be copied back up to the server to restore it. Every clone is really a full backup of all the data. Later, I will try to explain what do I mean when I say a repository, or what do I mean when I say a clone. What do I mean when I say a snapshot? So for those who might have questions about that, I will just share about them later. Okay. So this I've okay. I've included a picture of the distributed version control systems. Okay, so here you can see we have the server computer, which has version databases, and also we have different versions in there. And then we have this computer A and computer B, where like all the editing and the creation of files are being done. So say computer A can edit files and computer B can access them, and all of them, computer A and computer B, can be able to send or save those changes into the server computer. But right now it's not like in the same location. it's somewhere on the cloud. I hope everyone understand when I say the cloud, okay? And then furthermore, many of these systems deals pretty well with having several remote repositories they can work with, so you can collaborate with different groups of people in different ways simultaneously with the same project. So this allows you to set up several types of workflows that are not possible in centralized systems such as hierarchical models and everywhere. So I can summarize this by saying with distributed version control system, when they stepped in, people were able to, okay, they are able because it's what is going, it is available right now. People are able to work with their projects from anywhere in the world, like as long as you have your repository, you will be able to access your files, access all the changes, access all the histories, access with everyone, and also being able to share your projects uh, in from that server. So some history in back days before we had version control systems. First of all, let me know in the chat. Has anybody used torrents before or heard about torrents? Let me get the answer in the chat. Okay, so back in the days, people torrent, yes. So like people goes there and downloads movies, like files and some contents which they cannot find in the normal internet, right? Like Pirate Bay and everything. Yeah. So back in the day, that was the kind of the version control system where everyone was using. So if you wanted to have access to a certain software, that means first you have either to subscribe to the mailing list of the creator, or if it's a company, that means you have either to buy the membership so that every version when it is released, they send you the link where you can go and download your project. Okay, so if a new version comes out also, you have to do the same. Is how torrent works. So I can say torrent is kind of a representation of how old version control systems work. So back in the days, distributed source codes, people distributed source codes through patches and mailing list. So of course this was a bit cumbersome. However, it did not benefit from the distributed nature of email. So that means if you are not in the mailing list of the creator, that means you won't have the access of that software. So it's different from right now. You can just go in the internet and download the software when you need it. If a new version is released, uh, you just you will just get a notification and be able to download it. But back in the days, without this version control system, it was very difficult for them. So later, version control systems were developed so that we can be able to share and also collaborate on building these systems without having the limitations of sending files and receiving files, which took a lot of time and bundle, I can say. So the distributed version control systems like Git, Mercurial, Fossil, Bazaar, and others, they came out around 2005 and 4 to help solve the problem of having many developers working on the same project. So the original kernel of Linux, which I hope everyone is familiar with, and support from hosting servers like Google, Code, Bitbucket, and GitHub, uh, they become dominant version control systems today. And in Stack Overflow reports, it shows that the responses of Git is almost 87% of people are using it. And we migrated our code from archives to subversions and friends to Git, Mercurial, and friends. And finally, we settled on Git as the standard, I can say, that we are using up to now. So let's understand what Git is and the fundamentals of how it works. then using Git effective will be very much easier for us. Like I've said a lot of histories back, and also I've said a lot of, I can say, difficult stuff, but we are going to simplify them right now so that all of us can understand how Git works and how we can use it. So even though Git's user interface is fairly similar to other version control systems, like Git stores and think about information in a very different way. And you understand that difference will help with the help of avoid becoming confused while using it. So as you can recall, uh, if you have edited a content and then you have to share it with another person who has the same name of the file, same content, that means if you have to copy it from that file to your content, you will have to find every line and also paste it, right? But with Git, we can overcome these challenges. So it stores and think about information in a very different way, and it understands these differences with the help of avoiding becoming confused while using it. So Git, it stores the content in snapshots and not differences. So when I say snapshots, I mean like the line after line of the, let's say, code. If you've written 5 lines, that means the new documents will have maybe 105 from the original, which had 100. So that is what will be stored. And nearly every operation is local. So for example, you have your content in your machine and then you edit that same file. What will be done? It will be created a database which will hold that history. I know it might be confusing right now, but I will elaborate it later. And also, Git has integrity. If you read from the documentation of Git and GitHub, you'll see that it stores, like in encryption, all the information and it uniquely identify those data in the database so that you can go back and see what was changed in which time by who and what was the changes that were done. And the Git generally only adds data in that file apart from just creating in new files every time. So like it'll no more computers, if you want to change something in a document, as I explained earlier, that means you have to create a new, like modify the document and save as a new name. So that means you use a lot of spaces. But in Git, it only adds data in that file, also store the history so that you can access that file. Okay, so Git has 3 main states that your files can reside in. So we have modified, we have staged, and also we have committed. When I say modified, modified means that you have changed the file, but have not committed it to your database yet. What is commit? I will explain it later. So staged means that you have marked a modified file in its current version, but it has not went yet to a next commit or snapshot, or it has not been saved yet. And then the third state of committed, it means that the data is safely stored in your local database. And from this, I mean, we have we have 2 directories. Like the first directory is the one which exists in your machine, like the file systems. That's what I mean when I say the local database. That's the file that's like local file that you are working with. And then we have the repository or .git directory, which exists in your file system, but this one holds all the information about integrity, about encryptions, about histories. It is kind of a database which holds all the information about your changes of the files. So we have the first stage for when you shift your files in the working directory and you are editing them, they stand in the staging area. So let's say you have edited and it has been, let's say, notified as it was not it has been staged. That means you have marked it and modified it. so that it can move from one point to the database. It moves from the working directory and be in the staging area. And then when you commit it, it becomes stored in your Git repository. And when, let's say, you later we'll see how we can practice these version control systems to sharing these files and also moving them from one person to another, or from this database being able to be shared by many people, let's say collaborating with working with them. So like the basic Git workflow goes something like this. So you modify files in your working tree, which is the working directory, and then you selectively stage just those changes you want to be part of your next commit, which adds only those changes to the staging area. So let's say normally in your file system, without using version control systems, when you want to you have worked with multiple contents, it's either they become overwritten, okay, but uh, with Git workflow, you selectively stage just those changes that you want. So let's say you have worked with 50 or 100 files. You can selectively choose to save 5 or 6 files which you are comfortable, like this. Yeah, I can save these files and then continue with working with others. Apart from working in the local machine without version control system, you have to save all of them and work and continue working. So, and also you do a commit, which takes these files there in the staging area, and also stores this as snapshots permanently to your Git directory, or to your Git repository, or to your saver, which holds all the information about what changes were made and which lines were modified. And then if a particular version of a file is in the Git directory, it is considered committed. If it has been modified and was added to the staging area, it is staged. And if it was changed since it's checked out but has not been staged, it is modified. So we have to understand modification, staging, and committing. You modify when you are just modified but you haven't told Git to record it. And then you stage when you say like Git, note this file, it has been modified, please. And then you commit when you save, like you decide like, okay, Git, save these changes that I have made. Okay, so here comes GitHub now, after you have understood the Git. But before I move, I think I went very fast, so I don't want to let anybody behind. Let me take 5 questions and then we start talking about GitHub now. Okay, I guess there are no questions. Okay, so I continue. So what is GitHub? Pardon, someone was talking, right?
Okay, I just wanted to ask whether we are going to have a practical session for this and maybe talk about the nitty-gritties, maybe like Git rebase, branches and all that.
Everything, we touch them.
Okay, cool.
Okay, so GitHub is a code hosting platform for collaborating and version control. GitHub lets you and others work together on projects. It offers cloud-based Git repository hosting services. Essentially, it makes it a lot easier for individuals and teams to use Git version control and the collaboration. So there are various options of Git version control systems which are available, but to my options and others, I prefer using GitHub, and that's why we are using it here. So GitHub interface is user friendly enough to even notice coders can take advantage of Git without GitHub. So using Git generally requires a bit more technical survey and use of command line, But GitHub is so user-friendly, though some people even use GitHub to manage other types of projects like writing books. So GitHub has a lot of services, I can say. You can use it to host your codes. You can use it to collaborate. You can use it to build something, or you can use it to host something of your own. But additionally, anyone can sign up and host a public code repository for free, which makes GitHub especially popular with open source projects. So how can you use GitHub? So first, you need a GitHub account, which you can get through github.com. And then second, you have to install Git in your computer. When I say you have to install Git, I mean there is a Git desktop client, like it's an application which allows your computer or you to be able to run Git commands and also be able to use GitHub databases in your local machine. And third, you have to create a repository in your GitHub account. Okay, so can I share my screen now, or can you go and go to your account, GitHub account, and create a repository so we can see how does it look like? Okay, so when you want to create your new repository, you have kind of this interface. So a repository is like a place or a container where something is stored, or it's kind of a folder in your local machine. So in this case, we are creating a Git repository to store code. So we have options like you have first, repository needs a name, is a folder, it needs it. And then you have to select either it's public or private. When I say public repository, I mean this repository can be seen by anyone in GitHub. And private, it can only be seen by you or by other people that you have added. Okay, so then after creating your GitHub account, like your GitHub repository, you'll have instructions of how you can add your repository to your local machine. So to create a new repository in the command line, like in your local machine, you'll have to run these commands. Like the first one is echo hash new app readme, and then you'll have git init, and then you have to add the file that you want to add, and then you have to commit your file as I've stated before, and then you have to add the remote where the file exists, and then you have to push that content. I will explain it in a bit. So to tell your computer that demo is a directory managed by GitHub program, you have to go to the directory that you are working on, and then open terminal, or I can say command prompt, and then in that repository that you are in, and making sure that you have Git installed, like the application, you run commands git init. So here you are telling Git program to identify like the files that have been changed or something, and then to tell the Git program you care about this file and you want to track any changes from this pointer, you have to write git add. You can write the name of the file, or you can write git add. If you want to add every file that you have created, you have to write git add hyphen all. This will add all the files that are inside that file that directory that you have created. Okay. Yes. And then creates Can you create any file, let's say? Okay. Okay. So in this command, like git remote, add origin, and then the link to your to your Git repository, it states that we are telling Git to add. Can you put full screen your CMD? Put it in a full screen, your terminal. So as you can see in this command, like this one, we started with git remote. So we are telling Git to add a remote. A remote is a file that it's a directory that exists, or it's a file that exists remotely, or I can say online. So it adds a remote which is called origin with the address HTTPS that one. Okay, HTTPS github.com / your username / the repository that you have created there .git. So this is how you okay.
Is origin a keyword, or can you use another name, like let's say git remote add Raymond, then the name of the repository?
Okay, you can use like you're allowed to use any. You can say origin, or you can say Raymond. Yeah, it's allowed.
And what is its significance? Can you git remote add without the name? What is the significance of origin?
Okay, I've been holding that, but I can say, well, what I understand is that it's kind of for what I understand is that it's kind of what is how will it be treated? Like, is it the original file, or I can say it's kind of a branch, okay, where the repository existed from. That's what I understand, but I haven't never thought of creating, or I've never thought of creating, like adding the repository with a different name. But I think I can like, there's anyone who have answer for that? Let's see on the chat.
Well, personally, I think the origin part is supposed to be there because it's provided by the GitHub. I mean, yeah, in the instructions how to add. So it has to have like exactly this. When you create a new repository, it will exactly bring this statement. So you have to use it. You can't change it.
Yeah. But there is somewhere I seen that it states like it's not a must to use origin. You can use any name, but it didn't follow up why. Yeah, that's what I know. So I cannot say why, like what names are there, what other names you can place there, and why you should place them, or why you should use origin. But I used it because it is suggested by GitHub. I mean, in the documentation, that is how it states, and that's why. So this allows you to interact with your GitHub direct repository on github.com by typing origin instead of the full URL, and Git will know where to send your code. So, for example, now we have connected our local copy of the demo repository to its remote counterpart of github.com. So can you open that folder that you wrote git init in it? Or you can list, can you list the files in here? ls-a. Just here on the terminal.
You can check. I have listed.
Okay. Type ls-a, ls space -a. Okay. So you notice there is .git file or .git folder that has been created. Go inside this .git file. Go inside it. .git cd .git. ls. Okay. So see, by typing git init, we have initialized, and we have told our Git to create kind of a database, to initialize the database, which will be containing all the details, all the instructions of our files that will be changing. So this is kind of a database which will be holding all the details about our directory or repository. So you can see here we have branches, we have config, we have description, we have head, we have hooks, info, objects, and references. Okay, so after you have added your remote directory, that means you'll be able to create files in your local machine, and then be able to trace them or upload them to the GitHub account. So how do you do that? So first, we have already connected our local copy to the demo repository to its remote counterpart of github.com. Now that we have added the remote, we can push our code. And how do we do that? We use there are lists of commands that can be used by this. So let's say okay. Let's go back. Okay, hold there. So for example, you have created your files in your text editors, and those files are inside the folder that you have initialized, and also you have connected it to your remote. And when I say remote, I mean your repository which exists in GitHub. So first, to tell Git to recognize those files, as I have explained before, like to move them from the modified to staged, first you have to git init, and then you have to write command git add, and specifically you can select the names of the files. For example, you have written 3 files. You can write the first name, second name of the file, and the third name of the file, and then click enter. Git will document those files as will move the status from modified to staged. And then when you type the command git commit, okay, it has to be followed by -m. This is kind of a message, and this message helps you to identify, like you write everything that you have done. For example, git commit message first commit. This message will be saved in your GitHub history, and so that when you find this message, you'll be able to remember, like, okay, so this message, when I wrote it, I was working in this and this and this and this. Or you can write a description of what have you modified in this commit that you are doing. So after you have committed your files, they'll be moved in the statuses from modified, staged to committed. Okay. Okay. So then how do you move this file from your local machine to the online server? So you'll have to write a command which says git push -u origin main, or you can just type git push. All of these commands will help you to move like all the files that you have edited to your git repository. So for example, let's try with git push without your origin main. Okay. Okay, so first you have to run git push setup stream origin master. Have you got it? Okay, enter that. Okay. Are you sure in this directory you have you added the remote? Yes. In the documentation here,
you forget to add the default branch. I think you
yes,
git push and
yes.
tract, then master branch.
Yeah. Yes. So what is main? What is master? Please go back. Go back in the previous, like in your browser. There were some instructions there. Go back. Your browser. Go back in your history here. Go back in the history. Yes. Go back. Okay, it's gone. But when you create a new repository, there are instructions which will be there. You're not supposed to skip any of them, because at some point you can find some errors, and then you'll have some troubles to troubleshoot it and to know where you have messed up. That's why always when you find a documentation, you're not supposed to skip it. Okay, so by using these commands, like these 5 commands, we have seen how we can move, how we can practice this having these version control systems to create our file, initialize, commit, and also to move it from our local machine to online. See, so there are various operations we can do with GitHub. So as we have sent this file to our account or to our repository, we can now share this file or share this repository with someone else, so that they can also edit this file that we are working on, or they can see what we are working on. So how do you add a person to collaborate with in your files? So you go to your account, and then you go to your repository, and then you go to settings. Can we try that? Okay, and then you get to collaborations. Okay, you have to enter your password to confirm. Okay, here you can invite any peoples from which these people, if they are added, they can clone or they can download these files and also be able to see what you have done. Okay, for example, my username is Theogramma, PHEOG, yeah. And then that person will receive an email which they can respond to and be added as collaborators. So for example, I've received this email, so I'll be able to accept it and then be added as a collaborator. And as the collaborator, I mean, I can continue to work with this project, and or we can work together on this file or this project without having those interruptions, like this content already exists and various things. So this is how collaboration works. So for example, I have accepted the request and I want to access this file, or I want this repository to exist in my local machine. How do I do that? So first, I can use to download the file, or I can use a Git command called git clone. So first, I go to that account or that repository that has been shared to me, and then I go to code section, and then I copy the address of the user here, and then I go back to my machine, and then I open terminal. And then so I get write git clone in the URL, yes. Then I hit enter. Sometimes it will have to ask my username if the repository is private, and then also it will ask my password. So that's how I can make this project exist in my machine. And then, for example, now we are collaborators, right? You have your local repository, and I have my local repository, and currently we are collaborators in the GitHub, that repository. So that means if I edit something and you edit something, you will be able to commit and push it, and I'll be able to commit and push it. And it will be merged there in the repository. We'll find all our histories in there. So for example, I will clone this project here, and then we can try to work together in it.
I think you should share your screen now because you are cloning.
Okay. Can you see my screen?
It's loading.
Okay. Not yet?
Yeah, I think I should just share the one that I've cloned.
Okay. Maybe I can open this.
Do I create a branch or?
Yeah, so what I'll do, I will edit the files that you have uploaded, and then we'll create branches and try to merge those branches. Or I can, yes, we can do that. Okay. Okay, so I'll just be editing the files in this shared repository. Okay. Okay. Now, for example, this year, GitHub has improved like the method of accessing your accounts. For example, you want to download, or you want to clone, or you want to push your changes. Or you want to send your changes to your GitHub account. So you will have to create encryption key, and I'll show you how to do that currently. Oh, I cannot share my account here. I cannot share my screen. Okay, let's go back to the GitHub repository, to our GitHub repository, and see. You refresh. Okay, so we can see here, like I cloned this project, and then edited it, and then initialized, committed it, and pushed it to the GitHub account. And when you open the repository, you can see what was changed, what is the message that was written, and specifically you can open the content and see what was changed. So as you can see here. So for others who have experienced or have come through challenges, let's say you want to download you are, or you want to clone your project, or you want to push something, and then GitHub asks you for your password. Okay, you want to it asks you for a password. How can you create it? Oh, it asks you for keys, credentials. How can you do that? First, you have to go to your account, like to your GitHub account, and then go to your profile. Okay, and then go to settings. You have to go to your profile, and then go to settings, and then you have to find developer settings. Okay, so here you will find OAuth apps, which will have list of applications that you have given access to your account, or you can also create personal access token, and this personal access token can be used as a password or as a configuration password, which will enable you to be able to push and pull your changes or your repositories to your local machine. And why do you have to create personal access tokens? So due to security risks, just using normal passwords, it has been very risky. So that's why you can create different personal access tokens for different actions. So let's say you want to create one just for committing, you want to create another one just for editing or deleting, or let's say you have created automations with your GitHub account. You can create access token for that specific actions, so that you can just find over like, oh no, I deleted this with not knowing what I was doing. So with these personal access tokens, you can be able to control what actions you can access, or you can do with your in your account. So how do you do that? You open personal access token, and then you click generate new token, and here you'll have kind of a form where you'll have to, let's say, write a note or give it a name. Why is it for? And if it will expire, it will expire after a certain time. You have also to give it an expiration date, and then you have to select its scope. So in scope, first we have a repo. So like you give it repo access. For example, it can access committee status, deployment status, like select everything in here which applies to the actions that you want to be able to do with this token or this key. And then after creating this, when you go back to your local machine or to your terminal, once you want to perform a certain action, you can, when asked for a password, you'll have to copy this token that will be generated here and use it as the password for that action to be performed. And why do we need that, Cesar? I have already explained that we need this personal access token so that we can limit the actions that we want to perform. This also came very important because nowadays there is this thing called CI/CD, like automations of operations. You can create, let's say, a bot which performs various actions in your account. So to evade certain actions to be done without your approval or something like that, you can create that access here. Okay, so let's go back to our repository. Okay. Okay, so there is this tendency for GitHub users or collaborators when you both work in same file, or it sometimes happens that you have worked or you have written the same codes, or you have edited the same file, and then you have tried to push it. Okay, someone says here that on VS Code, however, I know so you don't have to. GitHub stop using password. Yeah. So on VS Code, somehow it doesn't ask you for password, but it depends on the operating system that you are using, and also it depends on the version of the. It depends on the settings or the plugins that you have in your VS Code. So let's say you have Git, you have Git plugins in your VS Code. That means you have logged them in your GitHub account. That means every time that you are performing an action which needs your password, automatically that plugin will deal with it. Okay, let's go back to what I was talking. So when a certain time you work with various contents like collaborators, and it happens you have edited the same content, there's something called uh, so like there's this something called conflict. Okay, so the conflicts may happen when you are all writing the same content, or you have modified the same file. So Esther, can you clone my file and then write a certain line after it, and then I'll write the certain line after it, and see, so that we can practice how we can have conflicts. I have edited main.js. Okay. 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 Can you save and try to, let's say, pull? Okay. Can you? There's this command that you skipped. Let me send this to you so that you don't end up with the same error again. Okay. Okay. So write this git. Let me just send it in the chat section here. Write this git branch m main. Yeah, and try to commit and then pull. You have not initialized. You have to git init. Oh, okay. Git init, git add. How to initialize space on the git here. Git commit, okay, and then pull. Try pull to pull. Not yet. Write git pull origin main or git pull origin master. Yes, master. Yeah. So this is like how it happens or what causes these conflicts. When a user or developers have worked on the same file and have done some changes in it without unknowingly, let's say. So Git create automatically it creates a conflict. So a conflict message comes like this. If you're using a certain code editor, it won't have these options like accept current change, accept incoming change, accept both changes, or compare changes. All right. So they will just show you like it starts with the head or current change, and the second one will be like what is coming. So here how can we know what is exists and what is incoming? The current changes or what exists in the person's computer will be on the first. Can I say the first part or the first bracket, and the incoming changes will be on the last changes. And how can you identify them? They'll be separated by this type of lines. So how do you solve the conflicts like this? So first, you have to identify what is different between these two lines. Okay, so for example, we have this is a sample text and this, and also we have this is a sample text. So this is where like while debugging, you have to choose like, okay, so this is what I written and this is what another collaborator have written. So you have to solve this so that you'll be able to push this code to online. And when you try to just neglect it and then push it, Git will not allow you to push it because there are changes or there are conflicts that has not been resolved yet. To resolve this, you can use if your code editor allows you, you can or you can accept current change or accept incoming, accept both, or compare the changes. But if you don't have that time to do that, you can just choose between the first one or the second one, or choose the content, which one to merge with which one. So for example, you can choose this is a sample text with purchasing bugs. You take this with purchasing bugs and you place it at the head or at the current changes that you have edited, and then you can continue to modify. But what I say here is that when conflicts happen with your Git is because of different editors have worked on the same file, and you have to solve them so that you can be able to to share it or to push it. So let us solve this conflict. Just accept current changes.
Okay, please pardon. There is something you said that if your editor does not give you the options at the top, there is a way that you can resolve the conflicts. How did you say you do that?
If your editor does not show you options to accept incoming or accept both changes, you have to manually do it yourself. Like you understand like what is current and what is incoming. So current is at the top and then incoming is at the bottom, right? So you have to choose which line to remove and which line to leave it, or if you want to merge, which content to copy from one line to another, and that's how you can solve it. But if you want to leave all of them, like the current and the incoming changes, you can just delete these brackets here and head, and then remove these equal signs here, and then remove this other bracket at the bottom with these share numbers. You can just do that.
So basically, you just eliminate the code that you don't want. If you don't want the incoming one,
yes.
you remove the share plus the code itself.
Yes. Okay. And also, like doing all this, you can just, if like your editor does not support that, you do it just manually like that. But if your editor supports it, that means you can just click those options shown there. So after editing, you have to save your document first. Save it. And then you have to initialize it first. Git add. And then commit. And then push.
Can you skip the initialize bit after you have resolved the conflicts? Like you just do git add and then git commit.
Well, you have to initialize. You have to initialize everything that you do on Git. Before you do anything, you have to initialize it, so that it identifies those files. It kind of identifies them. That's what I would suggest. Or we can try to just edit some file and then go directly to git add without it and see what happens. Can you try that? Okay, save it. Okay. You haven't saved the main.js. Okay, good. Oh, okay. Okay. So we can try to pull again.
I think for this, it is after you have resolved the conflicts, you have to post. So git push minus F.
Yeah, you have to push.
You said minus U or F?
Okay, I said minus F, but I think that is forcing it. So I don't know if
forcing it. It's not recommended. So when there is an error, it means there is something missing. So you have to go back and read it and see what it wants. For example, we can try to pull it. It's hint. It says like you have to git pull before pushing again. So let's see. Let's try that. To pull instead of pushing. Yeah. Okay. Push. Okay. Now let's try git init. Let's try starting with git init. And then git add. Then git commit. Then git push. Yeah, we have tried to pull, but it's not working. Anyway, without wasting time, we can learn about branches. So, for example, you might be working with a very big project, but you don't want to interfere like who is working with this and who is working with that. So you want each of you to have a different path or place where you are working with. So how do you do that? You have to create branches. So for example, you can how do you create branches? So you just go to your local, to your terminal, and then after let's say you have committed something, you type git branch, then the name of the branch that you want to create. Yeah, and then type the name of the branch that you want to use. Yeah. So from now on, Git will recognize all these changes that you are doing as they are in a different path as the main one, or I can say the original repository that is existing there. So we have different names or branches. So we have main or master. This is kind of the main one, which holds the original or the working content of the project. So if you are testing or you are working in different flows of the project, you can create various branches for different purposes. So let's say a person is working in user registration, can create a branch and then work in that path. And when that feature is working, can be able to merge to like link the branch that was created to that main or master branch. And then you can also be able to copy or to download or to revert all the changes that you have done in a certain time, to be able to pull them and see what was done in that specific time. So for example, you can push, let's say, the branch that we have created, and let's go to our Git account there and see how does it show. Can we go there? Okay. Can you open your browser, please, and go to your account? Okay, and then can you, let's say, refresh? I mean, go back to just to absolute path, like you just click the name new app here. Yes. So here you can see, like, this repository has received 3 commits in this time, and can you click that number of commits? Here you can see, like, the first commit, the message that was written, and then you see the sample, the second commit, and the third commit. When you click, let's say this one, if you are working with thousands of files, you'll be able to see the list of everyone here, every of those files here, and also you will be able to browse these files by this button here written browse files in the right, far right here. And also you can be able to force your browser or your repository or your database to identify this, the current working branch or current working file. So there are very many options or actions you can work with GitHub, and sometimes it becomes very harder to work with it by memorizing the actions, memorizing the commands that you might be supposed to use with. So there are a list of tools that come in handy sometimes, like they show you the history of files. They show you, you can preview every code that has been modified, and also it just reads your local database. So to name a few, the first one, it's called Sublime Merge. Do you have Sublime Merge, or you can try to Google it? Sublime Merge is Sublime Text, but instead of text, it's Sublime Merge. Yeah, that one. Okay, this application helps you to see, like, when you open your repository, like your local repository, it lists every files, it lists the whole history of your code, and also you can preview as you are previewing what was happening there on your GitHub account. And also there's another app. It is called Git Kraken, which work the same way as Sublime Merge, but this one has many features also. Git Kraken, yes, that one. So this one is very powerful than Sublime Merge. Okay, I wish I could be able to share my screen here so that I can show you how does it look like with this application and which actions or how many actions you can work with. So with these tools, as we have GitHub, as we have Git, and with these tools, it gives us power of doing various actions with our repositories and with our files with just a very simple commands. But GitHub is not only a place where you can just go to the next slide. It's not just a place where you can go to just to host your project, but also you can go to GitHub to participate in building different people's projects. And also you can go to GitHub to see like it records all the statuses. You can have issue trackings. You can collaborate in building other people's softwares. And by this, I mean open source projects, because currently, like everything that we are doing or everything that we are using in technology, it has started from open source. Like people's contributed to it, fixed some bugs, and that's how we were able to use a very good services that we are currently using. So GitHub has various services. So we have documentations. So some of us have come through books which were just written through GitHub, and they were hosted on through GitHub pages. So nowadays, you don't even need to have a website. You can just use your GitHub account and create a special repository like your name. Let's say Raymond.github. That's Raymond is your username of GitHub. So if you create a Raymond.github.io repository, that will be a special repository which, when you just find it, like through a URL, as you write let's say Raymond.com, you can use it as your website. You can just go and read it more about GitHub pages. And also we can automate various actions. So for example, from checking our commits, let's say I have shared something to my repository and someone else has contributed something to my repository. Instead of having these activities of just going there and review them, see what was done, see what was done, I can create automation through actions called CI, continuous integration and continuous developments, where I can create bots and automations so that they can just go through and check what was built and test them if they are right. And if they are right, be able to merge them and help us solve kind of challenges such as this we are faced here on merging the conflicts that has happened here. And also, you can find a lot of contributors. You can find a lot of projects. Let's say you want to work on a project, but you can find a template somewhere. But on the GitHub, you can find some of them are very free, and you can find network and even sometimes works. You can have discussions. Let's say you want to discuss like Stack Overflow, how it's going on there. Also in GitHub, you can do that. And also you can, if you have a project and it is working, people can become sponsors of your projects in GitHub, like give you money and so much more. And also GitHub has special services. So like GitHub pages, this is open to every GitHub user. and also we have GitHub Enterprise, this is for corporates which have very huge, I can say, huge softwares which needs a lot of works and everything. This can be offered to them. Okay, so GitHub and Git is not just something that you can finish discussing on the same day. So that means you have to start from, let's say, novice to somehow intermediate, and then you can become advanced. But for today, I can say I can just end up here, or we can prepare another session for a very deep dive about GitHub and its actions. But for now, I can start answering questions if available. Okay.
Okay, a question. I have a question on the difference between git remote add and git remote set upstream. What does each of these commands do?
Okay, so you have git remote add and git remote set upstream.
Yes.
Is that correct? Okay.
Yeah.
So git remote add, it adds the remote URL or remote repository. And GitHub set upstream, I can say, let's say you have the project which you have already added. You have already added a certain repository or a certain remote is the default or the one that can be accessed to when you want to push or pull from. If you want to change it to send to a different, I can say you can use GitHub, or you have changed it, you can modify it by using that GitHub setup stream. Or if there is anyone with a different answer, also welcome. Nobody else? Okay. Okay, next question.
There is a question on the chat, and Dennis is asking CLI or Git desktop. I think to rephrase it, would you prefer using CLI or Git desktop?
Okay, so to me, I prefer command line. Yeah, because it's kind of good. I don't know. It's my preference using command line apart from Git desktop, because what if I meet a computer which doesn't have GitHub desktop? Let's say I want to work in the servers. Servers don't have desktop. So while working with command line, I can practice and maybe memorize, have muscle memories about some commands, which will be very useful for me when I work with servers. Yeah. And some of people will have preference to Git desktop because it's just click of buttons. You have done a certain operation with just a click of button. You have you have pushed, you have cloned. Yeah. That's my preference.
And just to back up, I think also I would prefer the CLI option because it kind of teaches you now all the commands, so you understand them. How do you run them? And most importantly is when now you want to put your product or rather your project on production, some of the time you'll find that clients prefer either way. You need to host it on the cloud, of which now also you need to learn those commands, like how do you connect your project from development to production. So you need to understand the command as opposed to the desktop.
Yes. So also something, for example, you're working on a project, okay? And then there are certain files you don't want them to be added or you don't want them to be posted to your repository. There's this file, it's called .gitignore. Okay. This .gitignore contains the list of files that you don't want them to be pushed to your repository when you are committing or you are pushing them to your remote. So, for example, list of files that you want it to be pushed are kind of, let's say, secret server connection keys or encryption keys or API credentials and some kind of files like that. Okay, so here we have links from Esther on how, for example, you want to learn about Git. And also it's really great if I'll share the link for this slide that I was using so that you can go and learn or read for your own consumption, because I've included some of the links where you can go and have more reference and read more about. Okay. So here's the link of the slides. You can share it. Okay, so any questions? Any more questions? Okay. Well, on my side, I don't have much. I think for this these 2 hours that we are together, that's what I kind of prepared for today. So let me handle this back to Esther.
So if we don't have any questions, I think we'll wrap up the session. Thank you, Raymond, for taking us through the session. I'm surprised it took almost 2 hours, and the way I expected it to be 1 hour. So, anyways, personally, I've learned there are things that I didn't know. Weird thing, I've used Git and GitHub for a long time, but there are things I didn't know anyways. So I will send the link to the recording. We have a YouTube channel, so anyways, thanks for showing up. You can follow us on Twitter. You can also tell us what you learned today and also join us for the next sessions. Mostly it's about writing, so things to do with documentation and technical writing.
Okay, thank you.
Looking forward to seeing you again in the future.
Thank you.
So I think
Okay. Thank you.